All right, sets, here we go. 8.4, significance tests for a proportion. So this is very much related to 8.3, which was testing a claim about a proportion. So now we're just going to involve this 4-step process, if you recall. So just like chapter 7, in chapter 8, we're going to use this 4-step process for our significance tests. So the first step is you state. And what you're going to do is you're going to state the hypotheses. You're going to state the significance level and the parameter. So for your hypotheses, we're talking about H null, the null hypothesis, and HA, the alternative hypothesis. Your significance level is going to be your alpha value, and your parameter for the population proportion is P. All right, population proportion. Next, we're going to plan out what we're going to do. We're going to state the appropriate inference method for this significance test. We are going to do a one sample Z test for P. So notice we use this word test, right? And then we have to also check the conditions. There are 2 conditions. The first one is called the random condition, and the second one is called the large counts condition. Third, we have to do some things. We have to do our calculations. So first, we're finding our sample statistic. For this type of problem, it's going to be your p hat value. Then we're going to find our standardized test statistic, and that's our z, using that bigger formula. And then number 3, I'll put it here, your p value. All right, and that's going to come from the stats applet. And fourth, we're going to conclude. We're going to make a conclusion based on the hypotheses in context. So conclusion based on the hypotheses in context. And again, this is where you compare your p-value to the alpha value, right? And we either reject or fail to reject the null hypothesis. Fun times. Okay. All right. So let's take a look at our first problem. Example 1, who watches Survivor? Television executives and companies who advertise on TV are interested in how many viewers watch particular shows. According to Nielsen ratings, Survivor was one of the most watched television shows in the United States during every week that it aired. An avid Survivor fan and textbook author claims that 35% of all U.S. adults have watched Survivor. A skeptical editor believes that this figure is too high. He asks a random sample of 200 U.S. adults if they have watched Survivor. 60 say yes. Is there convincing evidence at the alpha equals 0.05 significance level to confirm the editor's belief? Okay, so the first thing we're going to do here is we're going to state what we're trying to do here. So state. So we're going to say we want to perform a test. Now we state our significance level at the alpha equals, and it was 0.05. If they don't give you one, you assume it's 0.05, but it's right here. At the alpha equals 0.05 significance level of, and now here comes our 2 hypotheses. Here's our null. It's going to involve p equals, and here's our alternative. It's also going to involve p, but I'm not sure yet what inequality symbol we're going to show. So the null proportion is 35%. So this is our p sub 0 value. So that's what's going to be used in our hypothesis, the null value. So the null hypothesis is that p is equal to 0.35. Now, this person says that he thinks that that figure is too high, meaning he thinks that actually less than 35% watch it. So we have to make this a less than symbol, less than 0.35. So there you go. And now we state what p is, where p equals. And now again, somewhere in here, we have to talk about what we're measuring. So we're looking at the true proportion of all U.S. adults who have watched Survivor. It's kind of stated right here. True proportion of all U.S. adults who have watched Survivor, right there, following the null proportion. P equals the true proportion of all U.S. adults who have watched Survivor. And there we go. So that's the state part. Good, we've stated. Now let's plan, all right? So automatically we're going to put, this is going to be a one sample z-test for p, right? Automatically, that's what we put. Proportions are always the z, standardized test statistic. We only looked at one sample and we're doing a test. And now we look at our two conditions. First is the random condition. And it says he asked a random sample of 200 US adults. So we're going to put random sample of 200 US adults. So good, random samples met. Now we're going to look at the large counts condition. Now to do that, we have to identify our n value and our p null value, our null value. So our n value, sample size is 200. Again, that's why I like to write it in the random condition. And then your p null value, again, is 0.35. So to test the large counts condition, we do n times p, 200 times 0.35. And when you do 200 times 0.35, you get 70. And that is greater than or equal to 10. We do 200 times 1 minus the null value, 0.35. And that's going to come out to be, got it, 130. And again, I should have known that because they just add to 200. And that passes the large counts condition. Good. So our conditions are met. We are good to do the problem. All right. So I'm going to erase this and we'll do the problem. All right. So now let's do it. All right. So when we do the problem, the first thing we're going to do is we're going to identify our three values we need. So again, you already have your n value written down. It's 200. You have your null value written down of 0.35. So now you have to find your p hat value by taking your sample 200 and seeing how many said yes. And 60 said they watched Survivor out of the 200. 60 divided by 200 is 0.3. Nice and easy. There we go. Okay, so now we need to find our standardized test statistic. So z equals, so it's our p hat value, 0.3, minus our null value, 0.35, all divided by the null value times 1 minus the null value, divided by n. And that's all inside the square root. Okay, and again, that can be a little herky-jerky to deal with, but if you, go slow, you should be fine. All right, so let's go do our calculator and type this out to get our z value. Almost done. Okay, let me open up a new tab for the graphing calculator. So remember when you type this in, first start with your parenthesis. Do the top, 0.3 minus 0.35. So you see it's going to be a negative number. Okay, in the bottom, put a square root. I like to type in SQRT. You can click the square root button. And then division to create your fraction. Null value times 1 minus your null value divided by n. Remember that square root has to include the n as well. And there is our z value. We're going to round to 3 decimals. So the 4 leaves the 2 alone. So this is z equals negative 1.482. That's our z value. And now we need our p value. And to find our p value, we got to use our stats applet. We need to remember that for our alternative hypothesis, right, we thought p was less than 0.35. So when we do the stats applet, we have to remember that less than means to the left. So when I use the stats applet, I'm going to go to the left of negative 1.482. So let's go there now. Stats applet, statistical applet, probability. Yes, it's normal because the large counts conditions are met. We're calculating area. We are always 0 and 1. And again, calculating area to the left, less than negative 1.482. When I do that, I get negative I get 0.0692. And again, let me just double check my values correct. Negative 1.482. Yes. Okay. So still within my do process. So my p value is going to be 0.0692. And then I want you to copy and paste this graph so I can see the normal distribution with that area shaded. Okay. And now we're going to do the conclusion. I'm going to do it right here. So again, we say p-value of 0.0692. That's going to be greater than 0.05. So because it's greater than, we fail to reject the null. Right? Not enough convincing evidence, right? It has to be rare. This is not rare enough. So we fail to reject the null. So we say there is not, if we fail to reject the null, there's not convincing evidence that, and now here's where your copy and paste goes. Copy and paste the P from the state that the true proportion of all U.S. adults who have watched Survivor and now you have to refer to the alternative hypothesis, right? This alternative goes right there. And in the alternative, there's a less than 0.35. And that's how you put is less than 0.35. And that's the conclusion. And that's the part we really care about, right? That answers this guy's question. So based off this sample, did he find convincing evidence of his belief that that 0.35 is too high? And the answer is no, he didn't. Okay? So we should not doubt that at least 35% have watched Survivor. All right, so this is our 4-step process of test. Again, it's very similar to what we did in chapter 7 with the 4-step process. All right, objective 2 is coming. Now we're going to look at 2-sided tests.